Hey everyone, M31 here. Now, Red Dwarf probably isn't the first show that comes to mind when you think cutting-edge science. It's a sci-fi comedy, and it's probably more smeg-ups than science papers. But like other things about Red Dwarf, if you dig a little deeper, you'll be surprised at how much real science sneaks in. It's white holes and black holes and holograms and stasis fields and time dilation, and even simulated realities, all mixed in with character drama, sarcasm, and slapstick. In this video, I break down the science-ish ideas behind Red Dwarf. Specifically, we're going to look at how the show plays with time. Let's start right at the beginning. Season 1, Episode 1, called The End. Dave Lister gets thrown into stasis, basically a booth that freezes time for anyone inside it. As Todd Hunter explains, time cannot penetrate a stasis field, so although you exist, you no longer exist in time. You're a non-event mass with a quantum probability of 0. Sounds like a complete sci-fi nonsense, right? Well, yes and no. There actually is a real phenomenon in quantum physics that sort of flirts with this idea, and it's called the quantum Xeno effect. So imagine watching a flying arrow over and over again. If you check it at every instant, it's basically motionless. In quantum mechanics, this isn't just philosophy, it's real. Scientists have shown that if you observe a quantum system rapidly and repeatedly, you can literally freeze its evolution. Atoms stop moving, and lasers have done this in labs. Of course, this only works on tiny microscopic systems, so don't expect to climb into a stasis booth anytime soon. Unless you're trapped 3 million years from Earth with only a hologram of your dead bunkmate for company. The very next episode, Future Echoes, throws us into another time trick. When Red Dwarf exceeds light speed, the crew starts seeing their future selves, paradoxes and all. Now, in real physics, Einstein's theory of relativity doesn't just allow for time travel, it basically requires it under the right conditions. The faster you move through space, the slower you move through time. That's time dilation. It's not science fiction, it's measurable. Astronauts on the International Space Station have technically aged just a tiny bit less than the rest of us because of how fast they orbit the Earth. So if you could cruise close to light speed, you'd return home to find decades had passed, while you'd only aged a few years. That's not quite as dramatic as seeing your own death over lunch, but still, time travel is baked right in to relativity. Then there's the episode called Backwards. Season 3, Episode 1. Crichton and Rimmer tumble through a time hole into a world where the time literally runs backwards. Of course, Lister and the cat have to chase after them and, of course, chaos ensues. Holly explains this with cosmic flair. Once the universe stops expanding and starts to contract, time could start running in reverse. Now, in real cosmology, there are speculative models where the arrow of time could flip in a collapsing universe. But don't expect a bar fight to neatly unrumble itself with chairs flying back into place and bruises magically healing. That bit, well, that's pure Red Dwarf. Now, one of the most fun takes on time comes in time slides. Crichton develops some photographs with some mutated developing fluid, and suddenly, you can walk into the photo. You can step into the past, change events, and rewrite the future. Science-wise, this one's probably more imagination than reality, but it does tie into the classic time travel question. If you change the past, what happens to the present? Butterfly effect, paradoxes, and in Red Dwarf's case, Lister becoming the rich slob inventor of the tension sheet, with 58 mansions and a private island in the Bahamas. Now, on to my personal favorite, the episode called White Hole. Instead of a black hole that sucks everything in, a white hole spits everything out, including time. The crew experiences the universe in scrambled chunks, time chopped and rearranged. And here's the cool part. White holes are actually predicted by Einstein's general relativity. Stephen Hawking himself said, "If there are black holes, there ought to be white holes. Objects things can come out of, but not fall into. One might speculate that you could jump into a black hole in one place and come out of a white hole in another. This would be the ideal method of long-distance space travel. Now, that hasn't exactly been proven, but it gave us one of the funniest, strangest episodes of Red Dwarf. And just a side note, I wrote a track inspired by it called Planetary Billiards. Keep an eye out for it when the EP drops. Red Dwarf just keeps finding new ways to mess with time. In The Inquisitor, a time-traveling simulant judges whether your life is worthwhile, and if not, deletes you from existence. And then in Out of Time, the crew finds a time drive, only to face themselves 15 years older and way worse off. And Ticket to Ride? Well, the dwarfers try to order curry in 1963 Dallas, accidentally altering the JFK assassination. Only Red Dwarf could combine Vindaloo with history. And what about Ouroboros? Lister discovers he's his own father, solving one of the show's longest-running gags. Paradoxical, bizarre, and very Red Dwarf. So yeah, some of these stories are pure science fiction. Others are rooted, at least loosely, in real physics. From quantum Xeno effects to time dilation to Hawking's speculation about white holes, Red Dwarf proves that you don't need to be hard sci-fi to play with fascinating scientific ideas. And honestly, some of the best episodes come from these wild science setups. They're clever, they're funny, and they sneak in just enough real theory to keep you thinking, right before the cat smashes Lister's guitar. That's it for part 1 of Red Dwarf's Wild Science. Next time, we'll dive into even more mind-bending ideas from the show. I'm Kyle, aka M31. If you enjoyed this deep dive, don't forget to like, subscribe, and check out the links in the description, including my music inspired by Red Dwarf's strange science. And I'll see you in the next one.